Hello, so I've got a question here that I've extracted from one of my A-level books, um, and it might have been a previous exam question, and I thought it could serve as some good revision as part of my equations and inequalities playlist. And so states here that the specification for a rectangular car park states that the length x meters is to be 5 meters more than the breadth. The perimeter of the car park is to be greater than 32 meters. So for A, it has to form a linear inequality in X. Okay, so first thing we can to understand, and I'll start here, down here, is that the length is to be 5 meters more than the breadth. And so if we were to draw just some arbitrary rectangular shape, I don't know, something like this, doesn't have to be so accurate. So you say that's x, and this is going to be 5 meters less than x. So you could write it x minus 5, like this, x minus 5. And we know that the perimeter of the car park is to be greater than 32 meters, form a linear inequality. So they just want us to set up basically an equality for the perimeter, and we know the perimeter is all the sides added together, right? So it's going to be x plus x minus 5 plus x minus 5, and they tell us that the perimeter of the car park is to be greater than 32, so we can set that to be greater than 32, and then we could just simplify this. It's going to be 4x minus 10, which is greater than 32. Oops. Greater than 32. So that's it. That's A, which is actually quite simple. I'm surprised. The part B looks like it might be easy too, actually. So it states that the area of the car park is to be less than 104 meters squared. So it's less than 104 meters. So the area is going to be less than that. Form a quadratic inequality. Well, we know that the area is going to be length times width, right? So x times x minus 5. And we know that the area is less than 104 meters squared. So the area is going to be x minus 5. And you could like meters squared, that's the area. But we know that it's going to be less than 104, so we can just write it this way. X times x minus 5 is less than 104. And that's our quadratic. They just ask us to form it, so that's the answer for part B. So now we've on to C, and it states, by solving your inequalities, determine the set of possible values of x. Okay, so this looks like where most of the work is in part C, and so by solving our inequalities, well, we can just start by working out the our linear inequality. Basically, what we have here is a linear and a quadratic inequality. And so we'll just start by working out the linear inequality. So 4x minus 10 is greater than 32. We just add 10 to both sides. We end up with 4x is greater than 42. And we divide by 4. I'll just scroll down. And we end up with 42 divided by 4. Well, 4, that's 10. It's 10 and 1 half. So x is greater than 10 and 1 half. Right, now that's for our linear inequality. Now let's work out the quadratic inequality that we have right here, and I'll just write it down the right hand side to save space. So it's x times x minus 5, which is less than 104. So that's x squared minus 5x, and then we can also subtract 104 from both sides here. I might as well, and that's now going to be less than 0. So with this, we just need to work out this quadratic. Now AC equals negative 104, and it has to add to 5. What multiplies to 104? Or negative 104 and adds to negative 5. 10 and 10 is 100, of course. 10 and 9 and 11, 8 and 12, 8 and 13. Okay, so yeah, 8 and 13, 8 and 13, and if it's negative 13, well, 8 times 13 is 104, and 8 times and 8 plus negative 13 is negative 5. So those are our two factors, yeah. So we've got x squared plus 8x minus 13x minus 104. Of course, is set to less than be less than 0. We factor out an x from this side, and we end up with x plus 8. Factor out a negative 13, and we know that 13 times 8 is oh sorry, I wrote 140. Should be 104. We know that 13 times 8 is 104. So we factor out a negative 13 here, and we get x plus 8 less than 0. And now we have x plus 8, or like x minus 13, which is, and that's of course less than 0. So what that is to say is, so for here, we don't have to rewrite this. The value x is greater than 10.5. That's we know that's the range of values here for this linear inequality. And here it's going to be x is greater than negative 8 and less than 13, which looks right because did they ask us to find where they overlap? By solving inequalities, determine the set of possible values of x. Yes, so they want us now to basically find where they overlap. And you know, you could graph this quadratic too to kind of get a sense of what's going on if you really wanted. Something like this. It's just a sketch. It's not going to be so accurate, but it's like this. It's an upward facing parabola. A is positive, so it's going to look something like that if that's the x-axis. That's the y-axis. They want us to find the possible range of values for x. Well, x is greater, so on the graph, like x is greater than negative 8, less than 13. It's going to be this range of values right here. Okay, and then we could draw this line as well, and basically we need to find where these sets of values overlap, and that's what we're going to do right now. And to do so, just draw a number line. It's probably the easiest way. We're going to have quite a few numbers on here. So it goes from negative 8 to 13. So let's just start at negative 9. It's negative 8, negative 7, negative 6, negative 5, negative 4, oops, negative 3, negative 2, negative 1, that's 0, it's about halfway. We got 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to need to extend this one, aren't I? So we'll do that. We're at 8, almost done. 9, 10, 11. Oh, I gotta extend it a little bit more. 11. Okay, make sure we have enough space this time. 9, 10, 11, 12, 13. Excellent. So, and actually, I want to take it to 15 just to get a bit of context where everything sits on this number line. 13, 14, 15. Okay, 13, 14, 15. So x is greater than 10.5. Well, 10.5 is going to be right here. So, and it's greater than, so open circle, and it's going to go that way. And here we know that x is greater than negative 8. So we could draw a dot here, and it's less than 13. And so, oops, in the middle, and I bring it all the way to 13. I'm going to have a dot right here. And so this is clearly right between 10.5 and 13. That's our set of values. And so we could say that x is greater than 10 and 1/2 and less than 13. 10 and 1/2 less than 13. And that should be our answer.